Right, guys. Now I think taking advantage of that, we've looked at the definition and the graphs of hyperbolic functions. I would like to take advantage and now look at the inverse of those functions. Let me start with this function and say sine hyperbolic of x. When this function is written this way, it's not really very clear because this word here sine becomes a kind of a black box working on x. But what you must not lose sight of is that this is e to the power of x minus e to the power of minus x all over 2. Then it is interesting for us to try to figure out how the expression for this function look like. Before maybe we can look about the graph, we're going to discuss the graph. The graph is easy. You are going to discuss with you the graph. I think it's going to be easy the case. But to say how does the expression of the function y equals to sine second function, sine hyperbolic second function of x. The question, how does this look like? That's what we think. Now, let's go back to what we said before. I said whenever you're looking for an inverse, you must think in terms of that the input is going to become output and the output is going to become input. If you lose sight of that trick, my friend, I don't know what you want to call it. I can call it a trick myself, but it's something else. If you lose sight of that, it's always going to be difficult for you to get inverse of a function. Now, let's see what happens here. Which means now in this function, we're going to say x equals to sine y, which we're going to say equals to e to the power y e to the power y minus e to the power minus x. Sorry, that is not correct. Minus e to the power y all over 2. Now let's focus on these two now. These two. Focus on those two. We're going to get x equals to e to the power y minus e to the power minus y all over 2. If you multiply by 2 on both sides here, I'll write it here. If you multiply by 2 on both sides, I'm going to get 2x equals to e to y minus e to minus y. The problem was sitting it here. We've got y and minus y, but you actually want y, isn't it? So we must try to look or strategize how can we get only y instead of y and minus y. The idea here, what you can use here is to multiply this thing by e y. Multiply the whole expression by e y. Then you get 2x e y equals to e 2y minus 1. Are we getting that? Okay. Now, if we then subtract this term on both sides of the equation, subtract this one on both sides of the equation, we're going to get e to the power 2y minus 2x e to the power y minus 1 equals to 0. And I claim this is a quadratic equation. The coefficients are 1, 2x, and minus 1. Minus 2x minus 1. What I'm saying here, you can rewrite this expression as e to the power y all squared minus 2x e to the power y minus 1 equals to 0. You can use the quadratic formula for this to solve this equation. If you use the quadratic formula to solve this equation, you are going to, I'm not going to discuss it thoroughly there, just try out to see that. Your A is equal to 1, the coefficient of this quadratic term. Your B is equal to minus 2x, because our unknown here is EY. You did want to find EY. Then our C is equal to minus 1. So you apply that formula, which says x, which is our EY, is equal to B minus B, which is going to be 2x plus minus square root of B squared, which is going to be 4x squared plus 4ac, which is 4 times 1 times minus 1, then you get a plus because there's a minus there. Then you get plus 4. All that over 2, which is 2 times 1. All together. Now, if you now use 2 as a common denominator, it's going to divide there. You're going to get x plus or minus. Here, you're going to get the square root of 4 times the square root of what? The square root of 4 times x squared plus 1. Do you see that? If you factorize, you're going to have 4x squared plus 1. So the square root of 4 times x squared plus 1. But the square root of 4 is 2. We did that yesterday, isn't it? Then you're going to have 2, but that 2 is going to make 1 with this denominator 2, isn't it? So what you're going to be left with there, you're going to be left with just x squared plus 1 with a square root sign on top there. Are we together? Now, let's just shift this a bit. Now, from there now, we are sitting with e to the power y equals to x plus or minus square root of x squared plus 1. Now, we actually want y, isn't it? Because that's our inverse, isn't it? So what are we going to do? To free y from e, what do you do? You multiply by ln. No, that's not the right question. You apply ln. Sorry, it's not multiplication. You apply ln. So we're going to apply ln this side. If you say ln ey, you're going to get y. Then on the other side, you're going to get ln x plus or minus square root of x squared plus 1, that. Then we're done. Then I think most of the time is up. I'm going to stop there. We're going to start from there in the next section and discuss that. I'm not going to work out every function like tan, cos, but the ideas which I've used here, I'm expecting you to take them to tan, to take them to cos hyperbolic, and they make sense of what's happening there. Isn't it? So really, if I'm going to evaluate sine hyperbolic of 0, what is second function sine hyperbolic of 0? Which means this is second function sine hyperbolic of 0, this expression. So I'm going to insert 0 there, insert 0 there, then I get the square root of 1, which is plus or minus 1. Then I calculate the absolute value, which becomes then positive. Then it becomes 0. So that function also passes to 0. Do you see that? It says 0 at 0. Put 0 there. 0, 0. 0 plus 1, 1. Square root of 1, 1. 0 minus 1 is minus 1. Absolute value of minus 1, 1. Logarithm of 1, 0. So that function is 0 at 0. Are we together, guys? Okay. Thank you for listening there. Our time is up, I think. Am I wrong?